Hi, in this video I'm going to finish up the week 1 notes. Start off with, let's run this line 79 from the note script that will create a object. Now I already had a object, but whenever you ran this, you should get one environmental object that says a object and even displays its value at the top right. Additionally, I have come down here, I have run the name of a.object. I didn't say anything to do with it because the default behavior in R for most classes of object are to just print them if you say their name without any sort of accompanying function. Now, let's try to apply a function to this. So I'm going to use the C function, that's the combine function. The combine function takes an indefinite number of arguments, which means I could have 1, 2, 3, 4 arguments, each separated by a comma, and that can just keep on going as demonstrated down here. I can even do things like nest functions inside of each other, but let's come back to that. So here it starts with the parentheses after the C and ends with the parentheses after the C. That's like capturing each of these different arguments inside of it. And then this right here is just my screen rendering a less than symbol followed by a hyphen. So my screen's just rendering that a little bit differently than your system might render it. When I then run this, the code completes. So what I did is I put my cursor really anywhere on this line. I pressed Control Enter because I'm on a Windows system, but a Command Enter on a Mac system would work as well. When I did that, that code got sent down to this bottom section. This is where you're actually communicating with R, not RStudio, and sending it to the programming language to start to do things. When I did that, it created an object, which is a character vector, positions 1 through 4. So here was the first position. This was just a length 1 character vector. Here's another length 1 character vector. Here's another length 1 character vector. Here's another length 1 character vector. Even though it's several characters long, it's a single value. And that just kind of gets us at this concept of value being like the whole situation inside of a position versus the position itself, which if I print this off becomes a little bit more obvious. Position 1, position 2, position 3, position 4. It is a length 4 character vector. If I print it off with a much narrower screen, we can even see that R tries to help us out here and prints off information describing where you are in the object as it gets printed out. So position 1, 2, 3, and 4. I could go on and create what's called a numeric object. That's going to be by changing it. It doesn't ask for any permission. It just allows you to override it. When I do that, it actually changes how it renders. We can see that now there are no longer quotation marks around each position. And so like it's actually now coded as a number. Now more on that later. That turns out to be quite important, but that's, well, this week's material. Last thing, if I don't assign the output of a function to anything, the function still occurs, but the assignment is often what you're actually looking for. That's where you're kind of saving the output into an object. And so like I can make my environment real big. Hey, I could even erase it, make sure I'm working from an absolute clean environment. And when I run this, if I run the right line of code, let me just do that again. When I run this, Control Enter, nothing happens. It prints off the message because that's the default behavior for unassigned data. But that's the end of the story. There is no object created. There's no like permanence to whatever just occurred. Now that's not going to be true for every function. There are functions that just do things under the hood, but most of R, and this was intentional when they programmed it, most of R does not change things as you run them. You have to really be more proactive and assign those changes to something. So again, not always true, but most of the time true. Like that was just a central tenet for their programming. The next thing is just describing operators. This is just a way of describing how symbols can be used as functions. In fact, they are just functions. If a function looks like this, it's the word of something and then open parentheses, a series of arguments separated by commas, and then a closed parentheses. I can make a function, technically, but in the form of an operator, like assignment, in that same syntax. I have to use these backticks, so that's the symbol next to your tilde. But when I do this, this will create the first argument will be the name of the object, and then the second argument will be the data to store inside of it, just as if I had made this the name of the object and this the data to store inside of it. So this is actually just a function. Same thing for math. Plus takes the left as one argument and the right as another argument, and it adds them together. Now colon, which I've kind of nested here, colon, let me make that a little bit bigger. Colon is another function. It is an operator because it's a symbol that means a function. And it stands for through. And so it will make series of values separated by 1. So this will be 1, 2, 3, 4, 5, 6, 7, 8 until you get to 100. This plus will then operate, and it will add 10,000 to each of those numbers. Now note, this is length 1 while this is length 100. However, R just assumes you wanted to repeat this one on the left. That's a process known as recycling, and will be yet another vocabulary word that's about to come up. But that's what's happening here. And note again, because I haven't assigned it to anything, it just gets printed out when I run it. Last one, that colon is actually just standing in for like a shorthand version of the seek function, which goes from one number to another number. And you can even go in and there's additional arguments that you can pass into it. And more on this later, but right now I could pass F1 to get some more information on how seek works. So a concept I just mentioned was recycling, where I had 10,000 plus 1 through 100. Because this was length 1 and because this was length 100, it had to repeat the smaller one in order to make this addition complete. That process is known as recycling, when that shorter value does get repeated. R does not ask about recycling. Sometimes it will warn you about recycling, and that's about it. So you actually have to be a little bit careful with this. It involves a lot of like running your code, making an object, testing it, seeing like, hey, I think that's going to be the number 10,000 repeated 100 times. But what if I was wrong and it was the number 100 repeated 10,000 times? Well, I could print it. And when I printed it, I would see, oh no, that's 10,000 repeated 100 times. And I would feel nice and confident. Same thing for over here. If I highlight what's inside the parentheses with the confidence knowing that according to PEMDAS, parentheses will come first. Now there's a lot more than just PEMDAS in R. There's a lot more order of operations. I usually just suggest to students just practice. You put parentheses anytime you're unsure, but practice is where you're going to learn it. There are just too many rules to really learn otherwise. Even I sometimes get surprised by order of operations at this point. But anyways, this is going to create 1 through 100. This is going to repeat 10,100 times. And when I add those together, I'll get the exact same value I got for line 101. It's just this time I've manually made this non-recycling. This one was implicitly recycling. This one was, I guess I could say I explicitly recycled 10,000, but nobody would describe it that way. This is just a non-recycling example. Finally, a non-element-wise addition. This is a little bit more challenging to describe. Element-wise is just this process of, all right, you took this position and added this position. You took this position and added this position, with each position also being synonymous with the word element. And so element-wise meaning like going across the element. And so position 1, position 1, position 2, position 2. And they add together in that order. That's what element-wise means. Now here I just tried to come up with some way of making a non-element-wise addition. Well, in that situation, I just took all of those values. I took all of these values and I summed them all together. So one big number from adding all of the previous. Obviously, this is not the same thing at all. This gives me a very different answer. I was just more trying to answer the question of, well, what would a non-element wise addition look like? But the real answer is addition is pretty intuitive. Element-wise execution is pretty intuitive right now. It becomes less intuitive when we start manipulating characters and you're not really sure like how the strings should get put together. Characters being like symbols that aren't numbers, but also including numerals, with the difference being between the value and the symbol for that value. But a character vector is comprised of a series of character values. Within any single character value, you can have a string, which is just like a string of characters, just to define some of those words for you. So at this point, I had some example questions for you. Create an object with the identifier my letters. It should contain separate values for each of the letters in your name. The length of my letters should return the number of letters in your name. So you should work on that. Pause. All right, I'm going to continue. Let's see. I said it should be my letters. So that's the name of the object. The values should be the letters in my name. So I could do this. However, the length of this is 1, not 5. And that's because this is a single character value, a string, in other words. If I want the answer to be the number of letters in my name, I have to stick them together somehow. And so here I am making separate character values or separate strings for each of the letters in my name. I'm then combining them into a single object using the combine function, the C function. And when I do that, I get a length 5 character vector. And as always in this class, I can check my work, usually using the stuff that me, Nolan, gives you in the code, and check to make sure I got this right. And I did. Next one, make a new script file named greeting script.r. Store it in the location described below. Did I give the right? Yes, I did. Good. It should create an object named greeting, assign greeting the value hello world. As the second line of code, print greeting. Check your code by the following and or picture in slide set. So you have to go back to the slide set from Thursday. First clear environment and then run the code, and then this should print. So let's take that into different parts. So create a new script file. Well, first of all, pause, try to follow along. You can do this. I believe in you. And if not, you can come get some help. So 3, 2, 1. Let's do it. So I'm first going to create a new file. If you can't see my screen, I just went to File, New File, R Script. I'm going to name it what was requested, greeting script.r. So I just copied that. I'm going to navigate to the right place. Now I was already in the right place, and I am personally on my own computer right now. I'm not on the EduPod. And so my saving location will be a little bit different. Just navigate where you need to. It should be in your home directory. On my Windows computer, that home directory is my documents. On the EduPod, it's the only directory you have access to. On a Mac, it looks a little bit different, but it looks a lot more like the EduPod. But at this point, I now have this updated that says greeting script.r, so it's got the right file name. I then say store it in the right location. I already did that when I was saving it. This script file should create an object named greeting, and I should assign the value to hello world exclamation point. Okay, so I'm going to create an object called greeting. I'm going to assign it the value hello world, except I accidentally doubled up my quotation marks. I'm going to run that. Hey, it's working. And then I'm going to have it print the object greeting. Okay. Well, let's see if it works. So did that. Check your code by the following and or the picture in the slide set. Well, I'm right here. I'll help you out. So here is my source. This is my home directory. This is the name of the main directory I'm storing all my code in for this class. Directory for week 1. Finally, the last part of this path is the name of the file. So let me clear my screen, otherwise this won't be very clear what's happening. So I'm clearing my environment as described right there. And when I run this, it will source the file. And source is just kind of like a new verb. It means to source the script file, and it will run that script file and do whatever it says, as long as it's written in R. So I'm just going to press Command Enter on this. It says object p greeting not found. I'm going to come back to my script file and be like, ah, man, there was a typo. So I save that, clear my environment again, run it one more time. Hey, now it is working. Great job. So that's sourcing. Sourcing just runs a script file. Very useful when you want to like put code into a file in order to organize it. Okay, so next up, I'm going to need to move my head because we're going to start using this help pane for a bit. So let me just, do I need to be on the screen? No, bye. Woo. Okay, so the help file can be accessed in a number of different ways. I could just manually navigate to it. That's way more long time taking than I usually do. I normally just use the question mark symbol. So question mark mean pulls up the help file for mean. Nice and easy. If I need to just find all of the help files for mean, I'm going to press Control Enter. This is going to take a few seconds. Not sure quite how long it will take. Depends on last time I did this search. Oh, that wasn't too bad. So this did a search of the names of the functions that exist. You can see I have a lot of different packages installed on my computer. And then it also did a search of the description. So if either one of those contains the string I searched for here, it will pop this up. And so I can scroll through here. I can try to find the like mean that I normally used. I scrolled down to the bottom to see if it was in stats. It doesn't seem to be, and that's probably because it's in base. It's a pretty base function. So just scrolling out there, it is base dates, date time. Oh, there it is, base mean. So that was the one that pulled up originally whenever I just searched for mean. But it does look, you can tell that there is a lot of other things related to mean. Now I could go and click on that, and it's going to take me to that place I pulled up the first time. Okay. Now, a few things to know about help files. Let's make this a little bit bigger. So just to give you a tour, a help file contains a bunch of information describing the function. There's a pretty standardized layout in R. It's one of the nicer things about R. And so they're somewhat easy to understand. Let's start off with this top section. This is a section you will be most often looking at. Like even me, having done this for a decade now, I am inside of this section of the help files on a daily basis. But inside of here, we can see the different arguments that are possible. We can see that this one actually has an ellipses, which means that I can kind of pass an indefinite number of arguments and it will do something with them. We don't really know what those look like. But all of this is listed underneath a comment that says default S3 method. And that's because it turns out that there are a lot of different versions of mean. That if I am trying to call the mean of something like a date, the math for that is different than the mean of just like a normal number. And so depending upon a concept called class, so like how is the data structured and intended to be used, more on that later, the way that mean is implemented might change. So here, this is like the default usage. Basically, you have to give it something. That's why it's saying right here, here is just for everything, you have to give it an argument called x. And that x argument is what it's going to call the mean on. However, depending on what that data is, it will do different things. Here is the version of mean that runs using like the default kind of base R objects. So the S3 method. We'll not really talk about some of the other methods in a lot of details, but we will definitely get there once we start to get into plotting, and then ultimately once we start to get into a bunch of bioinformatics systems. This describes what each of those different arguments mean. It's just basically a dictionary. It just goes through. It describes like what you can put in there. So right now there are methods for numeric and logical vectors, date, date time, and time interval objects. So if you run mean on any of those objects, it will calculate something, hopefully what you want. It also allows complex vectors. So that's things with imaginary numbers. But it requires some stipulations. So trim has to equal 0. Trim is a fraction of the observations to be trimmed off of each end. So that's of the distribution. So like from the 0th percentile, so everything, your normal implementation, to all the way up to 50%. Because if I trim off the bottom 50% and the top 50%, I guess I get the median is what this will end up returning. I'm not actually sure. I just use the median function typically to get the median. I guess that might be what that ends up doing though. We can see though that this argument has a default value, which I hope makes sense to you. If you had to like specify to not throw out observations every time you called mean, that would be insane. So there's a default value, and we can actually see that in how this says equals 0. X, on the other hand, does not have a default value because you have to give it something to analyze. NA.rm is currently set to false. That means that missing values in A, is what that stands for, will not be removed, which is just kind of this is a shorthand of writing this concept of should missing values be removed before, we just started sleeting again, should missing values be removed before the computation continues. So more on that later when we start talking about missing values, but they turn out to be very common in biology, and you really do have to pay attention to them. We could keep going down here. There's usually some extra stuff. Just going down here, it changes. It's a little bit harder to predict down here. Usually there's kind of a deep dive into like other cases or other types of values for giving these. Maybe defining further what this ... can be used for. Here it's mostly just information on trim because trim is kind of hard to understand. They've actually, I believe, updated this somewhat. But the last section I usually actually will be looking at is I start up here at usage, then I come down to arguments as needed, and then I'm often coming down here and looking at examples. We can even see some additional examples as a link. But this is some basic examples meant to help you out with a function. Sometimes they do a good job here, sometimes not. It's a bit of a random value. But that is help files. Quickly, there's a few different ways to get this that are a little bit more intuitive. So like if I wanted to say start writing the function plot, I could start the function. I could start here. Now, one thing to note, you're going to see this a little bit hard on my screen because of how I've got this currently zoomed in. But it's popping up a little box here that asks, that like prompts me, hey, for plot, you should give it an X and you should give it a Y. And then if I press tab, find tab on your screen, it also pops up a little bit of information. Now I say I look at help files daily, and this is actually how I'm typically looking at the help files. And then if I need to, I'm just like, oh, I need some more details on what X can be. And so you'll actually see down there at the bottom right of that top, maybe, that little pop-up box, it says press F1 for additional help. It's real small. But if I do that, it pops up some messages over here. Right now it's asking which version of plot do I want to pull up. And if I make that a little bit bigger, I can select that I wanted generic base XY plotting. And I can see here it's plot X and Y, and then it's got some ... And turns out plotting is pretty complex, so its help file runs on for a while. But we can see some of the major arguments up here that are possible. Now, if we needed to, we could click into this graphical parameters. I'll tell you right now, I'm not often going to ask you to go into base R plotting super deeply. The important part is that you're able to pull this up and start to see things like what the main should be, what the subtitle should be. And then you can go through and start seeing some different examples. So this is definitely a situation where they could probably do some improvement on that help file, which is why we covered it in class. So one thing that's interesting about R is that a lot of functions will change how they behave. And I'm going to zoom out for this. Will change how they behave in order to operate differently. So for this, I'm just demonstrating how if I give this a numeric vector, so a series of values, and I give y a numeric vector, a series of values. Did I actually run that? There it is, yeah. Well, when you plot that, well, if you imagine, if I take a bunch of numbers and try to plot y values of a bunch of numbers, that's a scatter plot. I'm describing a scatter plot. And lo and behold, if I run that line of code, x and y, it creates a scatter plot of those values on x and those values on y. And I can see two different distributions summarizing these values across three different species. And I can see one species, very, very obvious down here, separate from the other two, which are lumped together up here. Cool. LM stands for linear model. Now you probably experienced this function in R previously in your stats classes. However, I just wanted to point out, like when I run this, and here I've just assigned it to X, I haven't really told it what to do with this data. I haven't told it like X and Y values. I haven't told it like, I don't know, put sepal length on the X and petal length on the Y. I just told it, hey, as the input, do this object. But this object has the class LM. And because of that, it is going to end up plotting in a different way. In fact, if I came in here and I erased the end of this, having given X the value of a linear model, it is going to change its behavior. This is not what it says when I come up here and I type comma tab. And that's because it's changing its behavior based on the class. And it does this in real time. And so it turns out that there are different types of plots that you can create for a linear model. And so it's asking me which of them I want to make. If I wanted to find out where those were, that's where this dot comes in. This is why I suggest you don't use the dot. So plot LM, I could open up the help file for, and I could see what I'm actually working with. So note how this is different from the previous plot. It's one of those, this is that system of methods. These being kind of the default normal methods, this being a special method for LMs. So that's also the concept of class, that this function is changing how it behaves based on the input data. And it's by checking, well, what is the class of X? Well, the class of X here, class function, to find out the class of something is the function class. The class is LM, and so it uses the LM method. Very cool, right? Help files, really your friend here, and just kind of knowing that this system exists and that it's sometimes why this little pop-up message can be a bit confusing, because sometimes you have to just give it more information. So until I gave it a value for X, this is all I had. Once I gave it a value, it changed how it kept moving forward. It doesn't like it if I, let's see, we'll just give it a real simple linear model. Yeah, so now that I give it a complete sentence, it's able to kind of continue suggesting new ideas. All right, that is help files and how to access them. Really, you should be leaning into these tabs. Lot of good like just skills there. So this next section is just asking you to accomplish a goal. It's saying, can you make this happen, this code happen in a very small number of keystrokes? So I will tell you my process. I'm going to press M. And when I do that, nothing happens. I'm going to press E. Still nothing happens. So now I'm going to press tab because I think I'm getting pretty close to auto completing. So far I'm at 2. Okay, 3. I'm going to press tab again, and this is going to autocomplete. 4. Now, Air quality is an object that already exists. So I'm going to start typing. I don't think A is enough to get me there. AI might be. So I'm going to try AI. So that's, I don't know, 5 or so. I'm going to press tab again. And now it's trying to autocomplete air quality. I'm going to press tab again, and that's going to autocomplete. I'm going to press $ now because I personally know that an air quality is what's known as a data frame, and data frames can like be opened up using a $. When I type that $, all of a sudden it's going to start trying to suggest some additional ways of opening it up. And so I'm going to explore it now. And I'm like, all right, I want the ozone. So guess what? I'm going to press tab again. And it's going to autocomplete. Now here I'm going to press comma, tab, down arrow key, tab, true, and done. Now I stopped keeping track of my values, my count there. But the idea is that you are able to go through these help files using this tab. Oh, I just came back on. I did it myself. I don't know why I'm surprised. You're using this tab completion in order to help you write your code, to help avoid typos, to explore those help files as you're going through and like, all right, well, I need to remove missing values, things like that. T stands for true. I could also type this all out, but it does have to be all capitals. Note, if I don't make it all capitals, it remains a different color, and that's because it's not the concept of true, it's not the value of true. This is just going to cause an error. See, there is no object called true, but true has a value. More on that later. But this is just tab completion. You would not have known this without lots of experience, but I want you to get to that point. So really practice this, lean into it. In the long run, it's just like, you know, learning an instrument and just like learning what is like the ideal way to go about this. Well, you lean into the tab completion and you learn faster because you're seeing all these pop-ups, and you code more efficiently because, well, it's helping you. So I already talked through this, so I'm just going to skim through that. Hopefully you will get to there yourself. So this is just creating an example object for a question. So here is an object. This is then going to try and call the meaning of that object, but when I do so, I get missing. So I want you to go into that help file, go and research out the answer and try to fix it. I'm going to give you a countdown. 3, 2, 1. All right. Well, let's demonstrate that. Move my head again. Goodbye. So I come over here. I look inside my object. I'm like, cool. It's finding the mean of something, but I want to get the help file. Let me just try comma tab. Okay. I can see trim. It's not that. I can see na.rm and it's like, oh, yeah, I've seen na.rm before. I'm going to press tab again, not even needing to type it out. I'm going to type in true because it needs a true false value. And if I wasn't sure, I would just need to go and read that little pop-up again. And it says it needs to be true or false. Now, once I run it, there you go. I'm getting the mean of the values that are not missing. Now it brings us to how do arguments get assigned. I think that's the last concept in this notes file. And so let's go through it. Well, it turns out that user named arguments are always set first. They are set in order. If you set the same one multiple times, you get an error message. Now, basically user wins. If there's any default values, they get overwritten. However, what's complicated is when you don't name your objects. Now, first of all, that makes a very easy solution for all of you. You can just name all your arguments. You name all your arguments, there's no confusion anymore. But when you don't name your arguments, you need to base it upon the order because the remaining arguments are distributed to non-user specified arguments based on the order. So for mean, let's just pull that help file up. It goes x trim na.rm. In this example, I haven't named any of my arguments. That means that an object will become x, 0.1 will become trim, and t will become na.rm. So this will work. it will trim off 0.1 of the distribution, so those outer 10% of the distribution. That's based upon this description right here, and it will return the values of the inside data. Now this next one, just read through it, think to yourself, what's it going to do? What is each of these values going to become? Think. A 3, 2, 1. Okay, so X is named right here. User wins. So that is X. Now the remaining values are distributed in order to the non-user specified arguments, which means this T is going to go to trim because trim hasn't been set by the user yet. It does have a default value, but it hasn't been set by the user. And so that means trim is now equal to 1, which is not an allowed value for trim, which is why it's going to produce an error. NA.rm will be set equal to 0.1. Now it requires true or false, and this kind of depends on how they wrote the code for it. It won't matter because we will have already reached an error with the trim. But if anything, converting 0.1 to logical, or the function called as.logical, will return true because it turns out anything that's not 0 returns true. I think. Is it negative values also? Yeah. Anything that's not 0 returns true. So this will produce an error, but the error is because of trim. Must be numeric of length 1. Now, I'll note that the error message here, very strange, because T can definitely be converted into a number. So true can be converted into the value 1 typically. False gets converted to the number 0. But this is a concept called coercion, and it's a messy process. We'll have to talk about it more later. But that's what's going on here. Last questions. Find the standard deviation of an object. The function can be easily found using question mark string, so like standard deviation, or even guessed. So if you had to guess standard deviation, what would you think? Now, you've probably used standard deviation before, but somehow, let's see. Let's try question mark. Let's just try standard. If I scroll through here, come down to the stats, hey, there it is. It's SD. Had I just typed in SD, that also would have done it. If I'd come up here and I started typing SD and I looked at it, I could have pressed F1 and that also would have allowed me to pull this up. A lot of ways to get here, but SD looks a lot like mean. You have an X value, you have an NA.rm. It's a very common argument names. X is what it was before. So if I'm trying to find the standard deviation of an object, I just type it in here. If I wanted to change NA.rm, I would need to. Now let's see if I need to. Right now, an object, if I run it by itself, so I'm highlighting it and pressing Control Enter, I print it off. Hey, there is a missing value. If I ran this by itself, I'm going to press Control Enter. It prints off because I haven't assigned it to anything. I get an A. Probably not what I want. If I press a comma, press Tab, and find the argument I want to change, NA.rm, press Tab again, and now type in T for true. It will remove that missing value and calculate standard deviation across the rest of the data. Finally, and this is just true for most of my script files, my answers are often to the right. And so you could have seen the answer by just pressing enter. But that is the idea. So definitely go through that and practice it if it didn't make sense. Really, I think probably the hardest part of this is understanding how arguments get passed, starting to see the difference between things like objects, values, logical value here, and things like strings, as all different ways of kind of communicating data. This is numbers, logic, and character values or strings. But beyond that, get familiar with help files. I hope that helped.